Today we're moving into section 10.2 to find the side lengths of 45, 45, 90 triangles. This is going to end up being something you kind of have to have memorized. There's a certain pattern that the side lengths will always follow for these triangles. So we'll get to that in a minute. For our warm-ups, we are using the Pythagorean theorem to find a missing side length on numbers 1 and 2. 3 and 4, we're finding the value of x using the property of isosceles triangles. I'll give you a couple minutes to try 1 and 2 at least on your own. But just as a reminder, what is the formula that we associate with the Pythagorean theorem? Good. A squared plus b squared equals c squared. So on numbers 1 and 2, that's what you should be using. Okay, so I'll give you a few minutes to give those a try before we go over them. All right, on number 1, what did we plug in for A? 6. Okay, 6 works. That means B would be 8. We're looking for C. 6 squared.
36.
8 squared.
64.
When we add them together, and when we square root, we should get C is equal to 10. Questions about number 1? Okay, on number 2, we are looking for A. So what did you plug in for B?
12.
Good. 12 is the only option to plug in for B. We know that C is always the hypotenuse, or the longest side, or the one that's across from the right angle. 12 squared. 15 squared. Okay, here we have to subtract the 144 on both sides. We get a squared equals 81. Square root it, we get 9. So a equals 9. Questions about our Pythagorean theorem? Okay. On number 3, technically this is an isosceles triangle. Remember that whenever you have two base angles congruent, the sides across from them, here and here, those also have to be congruent to each other. So we could set up a pretty simple equation. 2x plus 8 equals 24. When we subtract, 2x equals 16. So when we divide, x equals 8. Same kind of situation on number 4, except this time we have the sides congruent. So that means that these angles across from those sides have to be congruent. So again, we end up with a pretty easy equation to solve. We would add 18 to both sides. So 5x equals 65. When we divide, we get x equals 13. Questions, concerns? Need more time on the warm-ups? Warm, fuzzy feelings? Okay, we'll jump on in. Find the missing side using the Pythagorean theorem. So these will be kind of like our first couple warm-ups. However, we might start noticing a pattern with these. So I'll give you a couple minutes to get the diagrams down and maybe try 5 and 6 and see if you notice something about them. Do not write your answers as a decimal. Write answers as simplified radicals. That's why on Friday we practiced simplifying them. All right, on number 5, if we're using the Pythagorean theorem, are we trying to find A, B, or C? C. We're trying to find the hypotenuse on all of these. So we would plug in 8 squared plus 8 squared equals x squared. What is 8 squared? Okay. When we add them together, good. And then we still have to square root them. Did anybody get a simplified radical there? It's a good place to start, but it can go a little further than that because the 8 could break down. Close. We already had that 4 out there. So when we pull another 2 out, good. 8 radical 2 is what we get when it's fully simplified. You got what?
I got 2 radicals.
So if we do this from start to finish with the 128. One way to do it would be 64 times 2. 64 breaks into 8 and 8. We already have a pair. We could stop. If you keep going, then you would end up with 3 pairs of 2s. 2 times 2 times 2 is 8. So if we were to keep breaking these down, 2 and 4, 2 and 4, 2 and 2, 2 and 2, we have 1, 2, 3 pairs of 2s. 2 times 2 times 2 is 8. This 2 up here is lonely. So no matter how we do it, we should get 8 root 2. Any other questions about how we got to 8 root 2? Okay, on number 6, we're also looking for C. So 4 squared plus 4 squared equals x squared. 4 squared is 16 plus 16. Anybody get that one simplified? Good, this one would be 4 radical 2. Box in my answers. Anybody seeing a pattern here? Yeah, they're all ending with a radical 2. And what else is special about them? You compare the answer to the original triangle. Good, so the number outside has been the other side length that we've been using. The number outside the root 2 is the same one. So let's see if that holds up down below. Some of you may have already done these. Again, we're looking for C. So 5 squared plus 5 squared equals x squared. 5 squared is 25. So we have 50 equals x squared. When we square root that, what do we get for x? 5 root 2. All right, one more. Same kind of setup. 3 squared is 9 plus 9 is, when we square root it, we end up with 3 radical 2. So this is kind of leading us into that pattern. So in the future, We won't necessarily have to do the Pythagorean theorem if we know we have an isosceles right triangle. Are we ready to move on? Okay. So, what do you notice about these? All answers are the number times the square root of 2. So that's our standard template for 45, 45, 90 triangles. Of course, you could write in on these that these are both 45 degrees, or you could mark that these would have to be congruent angles. Because the side lengths are the same, x and x, that's how we know it has to be an isosceles or 45, 45, 90 triangle. Anybody need more time filling in the notes on the front? Okay. Another way that we'll write this sometimes is that the hypotenuse, or h, is equal to a leg times the square root of 2, where h is the hypotenuse and L represents one of the legs. You want to add that in. That's how I might refer to it sometimes. Are we finding a hypotenuse or are we finding a leg? We ready to move on to the back? Lots of practice problems. On we go. Oh, well, see, there it is. I already put it up there. All right. Find the unknown side. The spacing on these is kind of weird, but I think you get the idea. This 15 belongs to this side. The 7 belongs to that side. Give you a minute to at least get the diagrams down. If you want to start filling in answers or thinking about what they should be, you can. Of course, we could fall back on our Pythagorean theorem for these, but we shouldn't need to. All right. On number 1, are we looking for a leg or a hypotenuse? Hypotenuse. So the hypotenuse is equal to a leg times the square root of 2. What is the length of the leg? 7. So our hypotenuse, which they're calling x, is equal to 7 times the square root of 2, or just 7 root 2. That's all there is to it. Honestly, when we have a quiz or a test, you don't even need to write out the original formula. You should be able to go straight to your answer. So on number 2, what do you think the answer is for x? 15 root 2. Again, we were looking for a hypotenuse. So we take a leg times square root 2. Number 3, what's our answer? 20 root 2. Same thing. We were finding a hypotenuse, so we take a leg times the square root of 2. Number 4, is it going to be the same type of problem? No, this time we are not looking for a hypotenuse. We are looking for a leg. So we can go back to that same formula, h equals L root 2. This time, what am I plugging in for h? 18 root 2. What am I plugging in for L? X. What do you think we need to do to get x alone? divide by root 2. So the root 2's top and bottom will cancel out. So x equals 18. So make sure you're paying attention to if you're finding a leg or finding a hypotenuse. It's the same formula either way. Might change your answer. Other questions before we continue? Concerns? Okay, on we go. Again, I'll give you a minute to at least get these copied down. You should try using the formula h equals L root 2. However, there's a little bit more simplifying involved on these ones. So you could at least start getting it set up. But we'll talk about how to simplify the answers correctly in a minute. So on number 5, are we looking for a hypotenuse or a leg? A leg. So what are we plugging in for the hypotenuse? Okay, 30. Ooh, it's ugly. 36 equals, what am I plugging in for leg? X root 2. To get x alone, I should divide by root 2. But on the left side, we don't have a root 2 to cancel out this time, which makes this one a little bit trickier. So I'm going to take away number 7 just for a minute to have a little space. Okay, so this is something that maybe it would have been useful to add to our review on Friday, but we cannot have a radical in the denominator. Who remembers how we fix that? Multiply by radical 2 over, no, radical 2. Radical 2 over radical 2 is equal to 1, and multiplying by 1 doesn't change a number. So we're just trying to rewrite it in a different way. So now we would have 36 radical 2 over, what is radical 2 times radical 2? Radical 4. Okay, and radical 4 is really just equal to 2. Now here's where it gets tricky for some people. Numbers under a radical can only be simplified with other numbers under a radical. So can I cross these 2's off? No, one's underneath, one is not. I can, however, simplify the numbers that aren't under a radical. So 36 over 2 is 18. So this ends up being 18 radical 2. Questions about number 5? Okay, I'm also going to erase 8 just to have some space to work out 6. On number 6, it's a similar setup. We're looking for a leg. They told us the hypotenuse is 24. We plug x in for the leg. Are we all okay with setting up our initial equation? Okay. Then after that, we're trying to get x alone. So we divide by root 2 on both sides. But we notice that it doesn't simplify nicely, and we cannot leave a radical in the denominator. So we do what's called rationalizing it. Root 2 over root 2. Now, while we're here, I will say rationalizing a denominator is not going away. Many, if not all of you, will take Algebra 2 next year. Maybe not all, many at least. Will take Algebra 2, and you will have to do this in Algebra 2. So, might as well ingrain it in our memory now. We start simplifying. Again, the square root of 4 is just a 2. What can simplify now? The 2 and the 24. So this becomes 12 radical 2. So x equals 12 root 2. Final answer. Questions about 5 or 6? Anybody need more time with it before I erase it? Okay. While we're paused here for just a moment. Tomorrow we will do section 10.3. Wednesday we will review, and Thursday you're going to have a quiz over 10, 1, 2, and 3. So quiz on Thursday. I would also probably expect a homework check tomorrow. All right, let's bring back 7 and 8. 7, 8. On number 7, we are looking for a leg. They told us the hypotenuse is 50, so we can plug it into our general equation and then start solving. Again, this doesn't simplify nicely, so we have to rationalize it. At this point, if you want to go straight from root 2 times root 2 to just a 2, I would be okay with that. If you multiply a radical by itself, you're just getting rid of the radical sign and keeping that same number. If you need to show the square root of 4 and then make it a 2, that's also okay. Here, what can simplify? 50 divided by 2 is 25. So we have x equals 25 root 2. Anybody have a guess about number 8? Good, 5 root 2. So you might have noticed a pattern on these. We're taking that hypotenuse number, dividing it by 2, and multiplying by radical 2. Now I would still want to see your work on these, at least the equation that you have to set up, and showing me your work for getting x alone. And at least show me that you're rationalizing. But a lot of these are meant to go really quickly. Five root 2. So we will learn this pattern that we've talked about today for 45, 45, 90 triangles. There's also a set of patterns for what we call 30, 60, 90 degree triangles. The 30, 60, 90s are a little bit trickier just because there are 3 different sides, whereas these ones are isosceles, so your legs are always the same. What questions do we have about 45, 45, 90 triangles? Nothing?